Hello everyone, welcome to Unit 7. We're going to be doing lesson 716, day 1 today. We're calling this lesson the complete unit circle because we are going to be filling in an entire unit circle today and filling this in with exact answers for everything. So we have learned about sine, we've learned about cosine, we've learned how to convert degrees into radians, we've learned a lot of different things. And now we can pretty much do this for all of what we call the special angles that are on the unit circle. All right, so what we are seeing down here is the unit circle. So like I said, our goal is to fill this in. And another way that we're going to do that is by looking for and making use of symmetry and patterns that we see in the unit circle. All right, this is going to be an invaluable tool for you to use later on if you get this thing filled in. This is something that you can use on your quizzes, that you can use on your tests. And I'm going to show you, after we get this filled in tomorrow, I'm going to show you how this is going to make your life much easier going forward with many of the different types of problems that you can use this on. All right, so do not gloss over this lesson. This is a very important lesson and worth your time. All right, so let's take a look at what we have down here. So like I said, this is a unit circle, which means each of these radius, or we call them radii, right? So each of these radii here are 1, right? We know that the length of all of those diagonals, or those radiuses, are 1, which is a big, huge clue when it comes to finding coordinates and things like that. All right, so you'll notice when we look in these boxes, they give us the angle measures for each of these points that are on the unit circle here. So for instance, this point is at 30 degrees, and what that's telling us is that this angle right here is 30 degrees. All right, and this point creates a triangle. Even though they don't draw the triangle in, we can. Right, so here's my height, and this is my horizontal distance, right? And we have talked extensively about how to find those two sides using sine and cosine. And this right here is the radius of the unit circle, which we know is 1. Okay. So one of these sides that we can find, since we want exact answers, which means we don't really want any decimals, we know that this side right here, this is the height, and we can find this by taking the sine of 30 degrees. Okay, and if I do the sine of 30, we're going to get 0.5. All right, so if I go to my calculator, I put this thing into degree mode, I do the sine of 30, I get 0.5, which we know in fraction form or in exact form is 1/2. Okay, so we get a side of 1/2 here, and then the only side that we really don't know is x. Now, we could do a cosine here. We could take the cosine of 30, and if we did, this is what we would get. We would get the cosine of 30 equals 0.866, and that is not an exact answer. We don't want to be putting 0.866 in for our answer because it'll get marked wrong. And they specifically said that they wanted exact answers. All right, so to help us with this, what we're going to do is we're going to use the Pythagorean theorem instead to solve for this side. All right, so we know Pythagorean theorem says leg squared, so that's going to be x squared plus 1/2 squared, and I'll put that in parentheses, equals our hypotenuse squared, which is 1. Okay, so we're just going to do a little bit of math here. We're going to say x squared equals, when we square x squared plus, and when we square a fraction, we square the top and the bottom. So 1 squared is just 1, and then 2 squared is 4. So we end up with x squared plus 1/4 equals, and then 1 squared over here is just 1. All right, so to continue finding out this other side, we're going to subtract 1/4 from both sides. And I'll clear this out of the way because we're going to need a little bit more room here. Okay, so the 1/4 cancel out. We find that x squared equals, if we do 1 minus 1/4, we get 3/4. Okay, we've talked about that fraction work before, so I'm not going to go over that again. And then to finish this off, we would square root both sides. Okay, so we get x equals, and remember, it's just like when we squared, if we square root a fraction, you square root the top and the bottom. So when we square root 3, we don't get a nice number, so we just leave that alone. So there's root 3. And then the square root of 4 is a nice number, we get 2. So that means this side is root 3 over 2. And now we can write our coordinates, right? So the coordinates are going to go in this box right here, and then we write it with parentheses and everything. So we're going to say root 3 over 2, that's our x coordinate, and our y coordinate is 1/2. And that's what will go here in the box. Now this box, this is for your radian measure, so we need to do a quick conversion of 30 degrees into radians. So we're going to do 30 times pi over 180. All we have to do is multiply here, so we get 30 pi over 180, which reduces to pi over 6. So we would put pi over 6 here in the radian box. Remember, no decimals in either one, right? It has to be all exact answers. All right. All right. So let's go ahead and clear all this out, and we'll do the next angle. And I promise it's going to get a lot quicker. Once we get a few angles solved here, we're going to use some other strategies to fill in the rest of this thing. All right. All right, so now just kind of going on to the next angle here. This is a 45-degree angle, so we can take care of the radian conversion first if we want. So let's do 45 degrees times pi over 180, right? And all of these conversions are going to be the same way, right? We're just going to take whatever the angle measure is here. We're going to multiply it by pi over 180, and then convert, right, to a reduced fraction. So 45. This will be 45 pi over 180. And remember, I showed you that trick on our calculator to help you reduce fractions. So if we just go to our calculator here and we do 45 divided by 180, remember, ignore pi when you're doing this in your calculator. So 45 over 180, we get 0.25. Then we go math, frac, enter, and you see we get 1/4, right? So we're going to get 1 over 4, and then we put our pi back. All right, so we know this is going to be pi over 4. Now we've got to go and find the coordinates. All right, so to do that, we have to draw on the sides of our triangle. So I'm going to draw my height, and I'm going to draw in my horizontal distance there, and then I'm going to trace over my hypotenuse. All right, so that way I'm focusing on the orange triangle. Remember, this is at 45 degrees, so this angle down here is 45, and try and ignore this this black line right here. For right now, we're just focusing on the orange triangle. Now we know the hypotenuse is going to be 1, right? And what we don't know is we don't know x and we don't know y. Now normally, like I said, we would take the sine of 45 and that would give us y. We would take the cosine of 45 and that would give us x. The problem is it gives us a decimal answer that's not convertible to a fraction. All right, so we have to use the Pythagorean theorem to help us out. So let's just set that up real quick. So it says leg squared. One of the legs is x, so we're going to say x squared plus our other leg, which is y, so we'll say y squared, must equal the hypotenuse squared, so we're going to say 1 squared. Now one thing that we have to remember about a 45-90 right triangle here, and this is a 45-45-90, is that the two legs are the same. Okay, x and y are going to be the same exact value here, right? So rather than doing x squared plus y squared, I'm just going to replace the y with an x, since I know both legs are the same. And you'll see why here in just a minute. All right, so now that these are the same thing, I can actually add them together. So I have 1x squared and 1x squared, which gives me 2x squareds. Okay, now notice that there's a 2 over here, so I'm just going to divide both sides by 2 to start getting x by itself. So we say x squared equals 1/2, and then we square root. Okay, so we can say x equals the square root of 1. Remember, we square root the top. The square root of 1 is just 1, so that one works out nicely. And then in the bottom, we get the square root of 2. And there it is. Okay, so we just leave our answer just like that. We can say 1 over root 2. And over here, we can say 1 over root 2. There we go. Now we have all three sides, and I can write my coordinate here. So I can say 1 over root 2, comma 1 over root 2. And that finishes off the coordinate for that one. Okay, so we have the 30 and we have the 45. You guys don't realize it yet, but at the same time, we are solving a whole bunch of these at the same time. We're going to be able to fill this in real quick. Like I said, we just got to get the 30, the 45, the 60, then we got to do the 0 and the 90, and those will be quick. All right, so let's reset a little bit here. And we're going to do the 60-degree angle next. Okay, so 60-degree angle, same way. I'm going to drop my height. We know the hypotenuse is 1, and we're gonna work on the other two sides. All right, so we have x and we have y. But before I do, I'm going to go ahead and do my conversion real quick to radians. So I'm going to convert degrees to radians. I'm going to multiply it by pi over 180. We get 60 pi over 180. I'm going to bring up my calculator here and do 60 divided by 180. And we'll do a quick conversion to a fraction there. So we get 1/3, right? So we get 1 over 3. So that's 1 pi over 3. So I'm just going to say pi over 3 for the radians. All right. Now, if you recall, for this one, if I draw in my horizontal distance and I'm going to trace over my hypotenuse here. So again, we're focusing on the orange triangle. Try and ignore these other two lines here. So I'm going to draw on my angle here. That's 60 degrees. That means this has to be 30, and you should recognize this triangle. It's a 30, 60, 90 right triangle, and it's the same triangle that we had over here when we had the 30 degrees, right? We had a 30, 60, 90 right triangle as well, and you might recall this side, the short side, 1 directly across from 30 was 1 over 2, right? So we can use that to our advantage. And then we also know that the long side, when we were dealing with this angle, was root 3 over 2. So I can say now y is root 3 over 2. And there we go. We have finished our triangle without the need for a Pythagorean theorem. And just notice that the x and the y values flipped here. So for my answer, for my coordinate, I'm going to say 1/2 comma root 3 over 2. Okay. Notice the only difference for the 30 and the 60 here was that x and y switch places, right? They flip-flopped. All right, so that's one of those patterns that we want to make sure that we notice as we go through and do this unit circle. All right, now we're going to backtrack. We're going to go to 0 degrees here. 0 degrees is the same thing as 0 radians, right? Because if we did 0 times pi over 180, well, 0 times anything is just 0. So 0 degrees and 0 radians are equivalent. Now, the coordinates for this one, there is no triangle to draw, but remember that the radius is always 1. Let me get rid of our 60-degree angle here. All right, so remember all of these radiuses, right? The plural of radiuses is radii, are all 1, which means this is 1. So if I'm looking at a coordinate, I went to the right one, right? So that means x is 1, and I did not go up or down at all. So that means my y value is 0. So we get that one there. All right. Now, very similarly over here, if I'm doing the coordinate for this one, again, the radius is 1, right? So going from here, I go up 1, which means my y coordinate is 1, but I did not go left or right at all, which means my x coordinate is 0. Okay, and we'll do a quick conversion here. Let's do 90 degrees times pi over 180, right? So you get 90 pi over 180, which is going to reduce to 90 over 180 is 1 over 2, right? It's half of 180, so we'd say 1 over 2, and then put the pi back in the top. Okay, so you can just say pi over 2. Okay. All right, so we've got the entire first quadrant filled in here. Now I'm going to show you some tricks. I'm not going to do this whole unit circle for you, but I'm going to show you some tricks that are going to really help you get the rest of this unit circle filled in. All right, so one of the things that you want to notice here is that these 2 points, they have the same height. All right, so this one here at 120 has the same height as this one here at 60 degrees, which means the y coordinates must be the same, right? So if this has a height of root 3 over 2 for the y coordinate, that means this one's going to have a height of root 3 over 2 for the y coordinate. Okay. Now, if I look at the 2 triangles for this, so let's say I draw on the triangle for this point. what you'll notice as I draw these in is that these are actually the same triangle. It's just this triangle has been reflected over here, right? It's like a reflection over the y-axis. So remember when we did this triangle, this was root 3 over 2, and this was 1 over 2. Well, this was also root 3 over 2, and this is also 1 over 2. But since we went to the left, this 1 over 2 is going to be negative. So when I go to fill in my x-axis or my x-coordinate here, I'm going to say negative 1 over 2. All right, and we can use that same strategy to help us out with almost every other point here on the unit circle. So for instance, let's do one in the third quadrant real quick. So let's get rid of this one. And what we're going to notice is that this point that we just filled in and this point also have a relationship, right? So if I were to draw this vertical in, what you're going to notice is that they have the same horizontal distance to the left. Okay, so they're going to have the same x-coordinate. Let me scroll down a little bit here. So for 240 degrees, we're going to have negative 1 over 2 as our x-coordinate. Now the y-coordinate, remember this one had a y-coordinate of root 3 over 2, but it gets reflected down. Now watch me draw on this triangle here. Okay, and I'll draw on this one. Again, you'll notice they are the same triangle, it's just that this one has been reflected down to be this one, right? So this one also is going to have a root 3 over 2 here, but since it's going down, it's going to be negative. So I can put in a negative root 3 over 2 for 240 degrees. So you'll notice I'm filling in a lot of these coordinates just using symmetry and patterns, which is really cool because I don't have to set up all of the Pythagorean theorem stuff that I did before. All right, now let's make the jump over here to the fourth quadrant. So if I draw in a line like this, you'll notice these 2 points, again, they have the same height. And I'm going to draw in my triangle for this. And again, you'll notice these triangles are the same thing again. They're the same triangle, it's just this one has been reflected over here, over the y-axis, and that means that this is also going to have a negative root 3 over 2. And remember that this side was 1/2, which means this side will also be 1/2. But since this 1/2 goes to the right, it'll be positive, whereas this one went to the left, so this one is negative. Okay, so for this point over here at 300 degrees, this is going to have a positive 1/2 and a negative root 3 over 2. Okay, so you see how we're kind of making the jump, right? So if I took this 45-degree angle, and I'll do this one in a different color here. Right, so if I took this 45-degree angle, this point and the 135-degree angle have the same height, right? And if I drew in those two triangles, you see the same triangle appear in both quadrants. Just one is a reflection of the other. So these coordinates, you'll use these again over here for the 135-degree angle. You just need to figure out which one is negative. And again, this triangle will appear again down here. So you'll use these coordinates again down here, but you need to figure out which ones are negative and which ones are positive. All right. So I think you guys are going to start to see the pattern here as you go through the unit circle. Lots of cool patterns to use. Once you start to see them, the rest of this thing is super easy to fill in. All right, and that's your mission for today. I want you to get this unit circle filled in. Make sure you convert, right? You have your degrees that you need to convert into radians. No decimals, all exact answers, and good luck. Let me know if you have questions in the Zoom chat.